All right, CalcC, we're back on the mic here. We're gonna get started with number 2. I'm gonna take the antiderivative of 3 times x plus 1 dx. And this is actually a pretty cool problem that I wanted to show you. If you are to expand this 3, this turns into 3x plus 3 dx. And when you take the antiderivative, you get 3x squared over 2 plus 3x plus c. Well, because there's no chain happening in here, you don't actually have to distribute the 3. The 3 just hangs out. So the other way we could have done this problem is done 3x plus 1 squared over 2 plus c. Are these actually exactly the same? Well, if I FOIL this out, I get 3x squared plus 2x plus 1 all over 2. Which is actually 3x squared over 2 plus 6x over 2 plus 3 halves plus c. Now this does actually reduce to 3, so these terms are exactly the same. But this piece has an extra 3 halves in it. Does that actually matter? Remember that when we take derivatives, these constants disappear. So you can actually think of this constant as having an extra 3 halves in it, and it doesn't matter. So while these two functions are different, they're only off by a constant, and so they both are antiderivatives of this same function. All right, so just to quickly go through a few of these. 3 over x plus 1, we know that the derivative of ln is 1 over, so when we take the antiderivative, we get 3 ln of x plus 1. The antiderivative of sine of x plus 1 is, well, the derivative of cosine is negative sine, so we have to account for that negative, plus c. Now for this one, for part D, we have 2x sine of x squared plus 1 dx. Now I see a product here, and I see variables, but I also remember I'm looking for something and its derivative. That tells me that I have u substitution. So if we let u equal x squared plus 1, then du is 2x dx. When I go u, I have to go all u. So this becomes the antiderivative. Instead of sine of x squared plus 1, it's sine of u. And instead of 2x dx, this whole thing turns into du. Whose derivative is sine? Negative cosine. So it becomes negative cosine of u plus c. For part E, I have the antiderivative of 3e to the x, the derivative, the antiderivative, all the same. And then for the last one, I have the antiderivative of e to the 8x. Remember that whether we're taking the derivative or the antiderivative of e to some power, we always start by rewriting. If I were to take the derivative, I would multiply by 8. So when I take the antiderivative, I divide by 8. For number 3, critical values. Critical values are the points where the derivative is 0 or where it does not exist. We're looking for those corners, those cusps, those discontinuities. Also, because we have a closed interval, we're going to look at our endpoints. So if y is x minus 2 to the 2/3, my derivative, 2/3 comes down, inside stays the same, but as to the negative 1/3, this derivative is never 0 because the top is never 0, but it is undefined at x equals 2. So my critical value is 2. I also have to check, so this is my only critical value, but to find the extrema, what am I going to check? I'm going to check my endpoints, so negative 6 something, my critical value, and my other endpoint. These y values are my extrema. This is my critical value, it is an x value, and these are all the possible points where extrema can occur at critical values and at my endpoints. All right, looking at number 4, evaluate the limit. I hope you look at this, you see it, you feel it. This is the definition of a derivative. This is asking you, what is the derivative of sine of x at x equals pi? Do we know the derivative of sine? It's cosine. Do we know cosine of pi? I really hope so. It's -1. All right, so now for the mean value theorem. What does the mean value theorem say? It says that if my function is smooth and continuous, that at some point in the interval, my average rate of change has to equal my instantaneous rate of change. This is why your mom knows if you average 70 miles per hour on a trip, at some point you were going 70 miles per hour, so you were speeding. So how do you find average rate of change? There is no calculus. This is just change in y over change in x. How do you find the instantaneous rate of change? This is the derivative. So if my function is f of x equals 18 over x minus 1 squared on the interval from 2 to 4. Now notice that this function is not continuous at 1. 1 is not in my interval, so this function is smooth and continuous on our given interval. So to find my average rate of change, I'm going to do f of 4 minus f of 2 over 4 minus 2. So this is going to just be f of 4 is 18 over 9 minus f of 2, which is 18 over 1, all over 2. 2 minus 18, negative 16 halves is negative 8. Derivative, how do I take the derivative? Well, f prime of x is negative 36 times x minus 1 to the negative third. So this is negative 36 over x minus 1 cubed. Mean value theorem says that at some point these have to be exactly the same. To find where that is, I set them equal. So negative 8 equals negative 36 over x minus 1 cubed. If I just cross multiply these bad boys, x minus 1 cubed equals 36 over 8, which is what, 9 halves? So x is, now if I want to isolate x, I'm going to cube root both sides, so I get the cube root of 9 halves plus 1. Is that in this interval? Absolutely. So there we go. All right, and then for the very last problem on this worksheet, oh, can you see my paper? So I want to show that the derivative. So if I have xy squared minus x cubed y equals 6. Because I have x's and y's in here, I know I have to use my implicit differentiation. I have a product here, so I get to use the product rule. So I have y squared times the derivative of x plus x times the derivative of y squared, which is 2y, and every time we take the derivative of y, we throw on a dy dx. That is not an x. Minus, again, I have a product. I need to use the product rule. So I have y times the derivative of x cubed plus x cubed times the derivative of y. What is the derivative of a constant? 0. A little algebra, get your, distribute your negative, get your dy dx's on one side. We end up with dy dx equals 3x squared y minus y squared all over 2xy minus x cubed. All right, so find all points on this curve whose x coordinate is 1. When x equals 1, how will I find y? Do I need my derivative for that? Absolutely not. I need to plug these into here. So when x is 1, I get y squared minus y equals 6. Y squared minus y minus 6 equals 0. Take me back to algebra 1. I get y minus 3 and y plus 2 equals 0. My 2 points are 1, 3 and 1, negative 2. Now find the tangent line to each of these points. So I have an x and I have a y. I have a point. What am I missing? A slope. Where do I find the slope? Joop. I'm going to plug it into the derivative. So I'll just do one of these points for you. At the point 1, 3, my derivative is 3x squared y minus y squared all over 2x y minus 27. So this is 0. If a slope is 0, I know my line is horizontal. The equation of a horizontal line is just y equals 3. So we could do the same thing with this point and plug it in here. For the last point on this worksheet, find the x-coordinate on each point, of each point where the tangent line is vertical. If my tangent line is vertical, what do I know about my slope? It's undefined, which tells me that the bottom has to be equal to 0. So if 2xy minus y cubed equals 0, 2xy equals x cubed, divide by both sides. So I get 2y equals x squared, so x equals the square root of 2y. Oh, I wanted to solve the other way. So y, which is delightful but not useful, y equals x squared over 2. What would I do with this? How would I find the x-coordinate? Again, this has nothing to do with the derivative. I'm going to plug this up here. So whenever I see a y, I'm going to plug in x squared over 2. So x times y squared, x to the 4th over 4, minus x cubed times y equals 6. And I'm going to algebraically solve for x. So hopefully this went really well for you. It jarred back a little bit of what you lost over the summer and the spring. We will have a Stuff We Know quiz this week and we'll do some more practice. But you can't keep going with the calculus without really mastering all of the derivatives. All right, I'll see you soon.